In this problem, a matrix A is given as 0, alpha, beta and 0 and is asking what will be the condition if a cube plus a is equals to 0. Now, we know that a cube plus a is 0, so I'll write it as a cube is equals to minus I. Multiply a inverse on both sides, so it will be a square is equals to minus I. Now let us find out a square. 0 alpha beta 0, 0 alpha beta and 0. Now if I multiply, it will be alpha beta, then 0 alpha beta. Now this is nothing but a square, and which is equals to minus I, which is minus 1 0 0 minus 1. So clearly alpha beta must be equals to minus 1, which is option D. Problem, we have to find the limit of integral y to a e power sin square t dt plus a to x plus y e power sin square t dt by x. Now, as the limit is from y to a and a to x plus y, I can write it as y to x plus y. So this can be written as limit extends to 0, integral over y to x plus y e power sin square t into dt by x. Now in order to find the limit of this expression, what I do is I'll use L'Hospital's rule. L'Hospital's rule. So we'll differentiate numerator and denominator separately. Differentiation of a to b f of x dx is nothing but f of b into f dash of b minus f of a into f dash of a. So here b is nothing but x plus y, a is nothing but y. So if I substitute that value, it will be f of b is nothing but e power sin square of x plus y into differentiation of b. Differentiation of x plus y is 1 plus 0 minus differentiation f of a will be e power sin square y, and differentiation of y is nothing but 0 by differentiation of x is 1. So limit x is tending to 0. So I can write this as limit x tends to 0 e power sin square of x plus y. Now as x is tending to 0, this will be e power sin square y, which is nothing but option A. Differentiate the function y is equals to x power x plus x power 1 by x. Now we cannot differentiate this x power x and x power 1 by x directly, so I'll convert them into two different functions. I'll take x power x as y1 and x power 1 by x as y2, and I'll apply logarithm. Logarithm of y1 is x log x here, and logarithm of y2 is nothing but 1 by x log x. And I'll apply UV rule, that is product rule, and differentiate this, and I'll obtain the value of dy1 by dx as y into x power x into 1 plus log x. Similarly, dy2 by dx is nothing but x power 1 by x square into 1 minus log x, and their sum, which is differentiation of y, will be x power x into 1 plus log x plus x power 1 by x into 1 minus log x by x square, which is nothing but option A. This problem, it is given that a die has 4 blank faces and 2 faces marked as 3. So a die consists of 4 blank faces, only 2 faces are considered marked as 3. Now he is asking, if it is thrown for 5 times, what is the probability that you will get 12? Now we will get 12 if out of 5 throws, exactly 4 throws are 3s. So and 5th throw must not be 3, so it should be blank. So exactly 4, it is nothing but p of x is equals to 4. We'll use binomial theorem here, and the number of throws here are 5. See, and what do we need? We need exactly 4, and the probability of getting a 3 is nothing but 2 chances out of 6 chances raised to the power of 4 into, and not getting is nothing but 4 chances out of 6 chances. And if we simplify, it will be 5c4 into 1 by 3 raised to the power of 4 into 2 by 3, which is nothing but option A. To find the area bounded between the regions y square is equals to x and x square equals to y. We know y square is equals to x is a parabola symmetrical along positive x-axis, and x square is equals to y is a parabola symmetrical along y-axis, and both the curves will pass through origin. Now we have to find this area. In order to find the area, first we have to find the limits. That means solving these equations 1 and 2, either you can get the values of x or you can get the values of y. Now if I simplify these equations, we'll get the value of x as x0 and x1. So the limits are 0 to 1, as we are taking the limits as x, now we have to differentiate this y to get the area. So 0 to 1, y in the first case is nothing but root x, and in the second case is nothing but x square. If I integrate, it will be 2 by 3 into x power 3 by 2 minus x cube by 3 over the limits 0 to 1. And if I simplify, then the answer will be 1 by 3, which is nothing but option B.
Minimum reinforcement in either direction in slab shall not be less than dash of total cross-sectional area. How much percentage of total cross-sectional area has to be there for the minimum reinforcement has to provide? According to IRC IS 456-2000, we know that 0.15% of total cross-sectional area the minimum reinforcement has to provide for the slabs. So option C is correct. For reinforced concrete works, what nominal size of aggregate shall be considered as satisfactory? As per IS 456-2000, the nominal size for reinforced work is recommended as 20 mm. So option C is correct. Here the question is, the unit weight of the soil is given as 14.9. Gamma is given as 14.9 kilonewton per cubic meter. The moisture content of the soil is given as 17%. So the water content given as 17%, that is equal to 0.17. The degree of saturation S is given as 60%, that is equal to 0.6. We have to find out the specific gravity of the soil solids. We know the relationship gamma saturation is equal to gamma by 1 plus W, that is water content. Gamma is 14.9 by 1.17, that is equal to 12.7 kilonewton per cubic meter. This is gamma saturated. We know the relationship between gamma saturated and specific gravity. Gamma saturation is equal to G plus ESR into gamma W, unit weight of water, divided by 1 plus C. So we have to convert this entire terms into specific gravity. So E is equal to Wg by Sr. W is water content. W is water content 0.17 Z by Sr. So by substituting these in this equation 1, gamma saturation is equal to 12.7, that is equal to G plus E is equal to Wg by Sr, 0.17 G into gamma W by 1 plus 0.17 G by Sr is 0.6. That is equal to, if we solve this equation, we will get gamma W is 10 kilonewton per cubic meter. So we will get the G value as 1.56. So option C is correct. A city's water demand is given as this much. What is the source water or feed water demand flow required for a brackish water RO if the plant recovery rate is given as 98%? So recovery rate is equal to Q feed source water demand into 100, that is equal to QF. We have to find out the feed source water flow required. QP is given as 26,500 divided by recovery rate is given as 98% into 100, that is equal to 27040. The value approximately to this in our options is B. So option B is correct.